Okay, so the spectrum peaks will appear at the resonance frequencies of the vocal tract, and the resonance frequencies of the vocal tract are called formants because they form the spectrum. Yeah, now let me see. I could also take a pulsating airflow, because if you want to hunt ducks, you should have one of these. It is a membrane that will start to vibrate if you blow if you pass an airstream. So is what ducks like, and it is a pulsating airflow, and I could let that go. All the partials that is constituting this sound could travel through the vocal through this tube, and then you will hear that it doesn't sound like a duck anymore. It sounds like a it sounds like a neutral vowel, actually. So, and I think this is very, very thought-provoking, that this vocal tract shape, is cylindrical, and when we do not know what to say, we use a cylindrical vocal tract and say like a feeler kind of thing. Anyway, so everything is very thought-provoking. Okay, so the pulsating airflow plus a tube, that means the transfer, the frequency curve that goes up and down in peaks and valleys, they produced a vowel sound. The formant frequencies, the resonance frequencies of the tube, they are determined by the vocal tract shape, as I suggested just a minute ago. So if I put a constriction somewhere here, the resonance frequencies of the tract will change, and we are of course very skilled in creating vocal tract shapes of different kinds. So here, when we say the vowel E, we have the tongue up front in the mouth, and that means then that the pharynx is a very wide cavity, and that we have a variety of these vocal tract shapes. So, for instance, the vowel A is created with a very narrow, deep pharynx, and the vowel O is created with a constriction of the pharynx a bit higher up than the A, and the U, there you constrict the vocal tract in the corner, and the E and E have a similar tongue shape, but E has a narrow jaw opening, and E has a wider jaw opening. Yeah, that is that. So now you want to see proofs of that, and therefore I brought also a flexible tube which I could squeeze at different points, and then you would expect different vowel sounds to emerge, of course, because what you saw here. So if I squeeze the tube down in the bottom end of it, it should be a vowel, and if I squeeze it in the front end, and quite a different vowel. And I could even try to do this vowel. Then it should be narrow in the middle and also in the front end. So something like this. Yeah, how about that? It's a tube. Now, and I could also shift between posterior pharyngeal and oral constriction.